Given the characteristics of a polynomial function, draw the graph and derive the actual function. In part A, we'll graph a polynomial with the characteristics shown. Draw x-intercepts at -1, 0 and 3, 0. The trendline of a fourth-degree polynomial with a positive leading coefficient matches an upright parabola. Sketch the polynomial so the graph passes through the point 1, 8. We can draw this using a multiplicity of 2 for each 0. Now we'll find the polynomial. Set up a polynomial template using the known roots and multiplicities. The leading coefficient a is unknown, so we need to calculate it before we can write the actual polynomial. Plug in 1 for x and 8 for p of x. Simplify. This gives us 8 equals 16a. Divide both sides by 16. Reduce the fraction. The value of a is 1 over 2. The polynomial is p of x equals 1 over 2 times x plus 1 squared times x minus 3 squared. Now we'll move on to part B. Graph the polynomial with the characteristics shown. Draw x-intercepts at -3, 0, 1, 0, and 4, 0. The trendline of a third-degree polynomial with a negative leading coefficient matches the line y equals -x. Sketch the graph so it passes through the y-intercept at 0, -3 over 2. We can draw this using a multiplicity of 1 for each 0. Note that the relative maximum and minimum are not required to find the function, so we can guess their position. We can always adjust the graph after finding the function. Now we'll find the polynomial. Set up a polynomial template using the known roots and multiplicities. The leading coefficient a is unknown, so we need to calculate it before we can write the actual polynomial. Plug in 0 for x and -3 over 2 for p of x. Simplify. Simplify further. Cross-multiply. Divide both sides by -24 to isolate a. Reduce the fraction. The value of a is -1 over 8. The polynomial is p of x equals -1 over 8 times x plus 3 times x minus 1 times x minus 4.